you?
Fine.
Okay. This lesson is revision work. Last lesson was about combinatorics, wasn't it?
Combinatorics is a branch of mathematics which concerns counting problem and it applied in physics, biology, statistics and probability. It finds out all the possible way to arrange any distinct object out of a set.
Okay.
And it concerns permutation, disposition, and combination.
Okay. Thank you. Alexa, can you show me
An example?
an example of
Yes.
permutation?
For example, we have three chairs, number 1, number 2, and number 3. And we have three equal letter A, letter B, and letter C. The first possibility is letter A, sit on the chair number 1, sit on the chair number 1, letter B, sit on the chair number 2, and the letter C, sit on the chair number 3. The second possibility is letter A, sit again on the chair number 1, letter B, sit on the chair number 3, and letter C, sit on the chair number 2. The third possibility is letter B, sit on the chair number 1, letter A, sit on the chair number 2, and letter C, sit on the chair number 3. The fourth possibility is letter B, sit on the chair number 1, letter A, sit on the chair number 3, and letter C, sit on the chair number 2. The fifth is letter C on 1, letter B on 2, and letter A on 3. The last is letter C on 1, letter A on 2, and letter B on 3.
Okay, let's sum up. If no one is standing on chairs, we have three possibilities of sitting on the first chair. If one person is sitting on the first chair, we have two possibilities of sitting on the second chair and, of course, one on the third chair. So, all the possible arrangements are P3. That is to say, 3 times 2 times 1 equal to 6. This is the formula, and this notation is n factorial, and it is a product of all positive integers less than or equal to n. This is the definition. Maria, in a race of 7 fleets, in how many ways can they finish?
It's 7 factorial equal P7 equal 7 factorial equal 7 times 6 times 5 times 4 times 3 times 2 times 1 equal 5,040.
Okay, very well. Let's master another kind of arrangement. We have, in a race of 7 fleets, we want to know in how many different holders 3 of them can stand on the podium. Okay.
It's a disposition of 7 elements to at a time.
Okay. In this case, on the first place, we have 7 possibilities. If one fleet is standing on the first place, we have 6 possibilities for the second place, and finally 5 possibilities for the third place. These are disposition of 7 fleets taken 3 at a time. The calculation is 7 times 6 times 5 equal to 210. Okay. In this case, both the orders and the nations of element are important. This is the formula. Okay. Let's pass to the last kind of subset. We have this example. Okay. We have 4 flavors of ice cream. and we want to make 2 flavors ice cream cones. Okay. In this case, Emanuele, is order important?
No, no, it isn't, because if I eat strawberry or vanilla or strawberry, it is the same thing.
Okay. We can consider this position of 4 elements taken 2 at a time, which are 12. But we can cancel the duplication. Okay, strawberry, vanilla, pistachio, vanilla, chocolate, vanilla, and so on. So we can have a combination of 4 elements taken 2 at a time. Okay. Can you tell me the formula?
Yes, it is a combination of 4 elements taken at a time, equal disposition for 2 over permutation 2, equal 4 times 3 over 2 factorial, equal 6.
Okay. Okay, this is the formula. Okay. Emanuele, last question. If we have 7 pleats, okay, how many combinations we can have?
It's a combination of 7 athletes taken 3 at a time. The calculation is disposition 7 over permutation 3 equal 7 times 6 times 5 over 3 factorial equal 35.
Okay, very well, that's done. Let's toast.
Grazie.